Hello guys, very welcome back. In this video we'll be talking about the distribution of salinity, both horizontal and vertical distribution of salinity we'll be talking. Now let's first see how the salinity varies horizontally. Horizontally means on the surface. Okay, we'll see latitudinally. Now if we see latitudinally, the 0 degree has lesser salinity as compared to the tropics. That is, equator has less salinity as compared to the tropics. As I've already discussed, the equator has less salinity as compared to the tropics, because at the equator, though the evaporation is quite high as compared to that of tropics, but at the same time the precipitation is also high at the equator, by which the fresh water influx reduces the salinity as compared to tropics. So a depression is seen in the graph. Okay, now as we move towards the tropics, as I've already told, the salinity is maximum, as then in middle it's lesser, and in poles the salinity is the least. Okay, so as I've already told, the equatorial zone of relatively low salinity, the tropical zone of maximum salinity, the temperate zone of low salinity, and subpolar and polar zone of minimum salinity. Now next, if we see the vertical distribution of salinity, right? Now if we compare the vertically 300,000 meter, 2000 meter with respect to the salinity, here ppt represents parts per thousands. Okay, now as I've already talked, if we start with the tropical, the tropical has the maximum salinity as already talked, right? So salinity decreases. Why the salinity decreases from the 0 meter to 300 meter is because the tropical zone experiences influx of fresh water. That's why the salinity at the top is maximum. Okay, let's restart again. Now first we'll see the vertical distribution of salinity. Okay, now if we see the vertical distribution of salinity, I have all compiled in just 3 graphs. Now if you see let's start from the equatorial region. Okay, now first of all, since we know equatorial region has a lesser surface salinity as compared to the tropical region, and why is that so? I've already discussed. Okay, now the question comes, the tropical and the equatorial region, as we go down, the salinity decreases. This is because up till around the photic zone is limited. Since the photic zone is limited to its depth, similarly the evaporation is limited. Evaporation is directly linked to salinity. Now since evaporation is maximum at the top, salinity is maximum at the top, and hence it decreases as we go down. Now at 300 meter below the surface sea level, the salinity of both the tropical region as well as the equatorial region comes at the same point. Okay, somewhat very near to 36, and the graph, they toe each other. Okay, this is the same graph. In order to represent differently, they are separated. If we come to mid latitude, it's very similar. The salinity is between 35 to 36, 35.5, and it decreases as we go down. Okay, now this zone, if you see this zone, the salinity is, the decrease or increase in salinity, as in case of polar region, is very high. Okay, now in the polar region, if you see the salinity starts from 0 to 10. It's not 0 and it's not greater than 10. The salinity starts from 0 to 10. The reason why the salinity starts from 0 to 10 in polar region is because polar region experiences 2 things. First of all, the photic evaporation, the photic lead evaporation is very less because the sunlight experienced by this region's water is very less. Secondly, the fresh water due to the melting of the glacier in summer times is another reason why the salinity decreases drastically. Okay, again same for subpolar region, but since subpolar region is little more towards the photic lead evaporation, the salinity is higher, quite near to 33 grams per 1000 gram of water. Now the reason why it increases as we go down is because the stratification of the saline water below, because as you know the as we go because see, saline water is relatively denser as compared to the fresh water, right? So as we go down, there is stratification of water, right? 33, 35, 36 and so on. Now since this stratification is there, and this stratification dominates over the evaporation lead photic part in polar and subpolar region, and hence we have this graph, okay, of increasing salinity. Okay, now the question you will ask, why doesn't the stratification comes into the picture here? As I've already told, the evaporation leads, it has an edge over the stratification of water, and hence lower the salinity here. Okay, now a very important term, you will see this zone in both of them, they have a very high degree of slope. Okay, so this zone of 300 to 1000 meter depth where the sharp change in salinity is observed is known as halocline. Halo is saline, cline is very abrupt or rapid change is known as cline. So this is known as the halocline. Okay, next video we'll see some of the examples, some of the other factors which influences the salinity. Okay, we'll see some examples like that of the Dead Sea, China Sea, the sea in Utah, the Great Salt Lake, etc. Okay, see you, bye, take care.